Okay, class, for section 5.3, we have section C, scientific notation. Before we begin scientific notation, let's review what we learned about writing products in standard notation when multiplying decimals to the power of 10, as we did on page 130. So now we have 2.6 times 10 to the 7th power. We know that we will move this decimal 7 places to the right. So it'll be 2, 6, 0, 0, 0, 0, 0. So our final answer here would be 26 million. We have 1.1 times 10 to the negative 4 power. We know we'll move this decimal to the left 4 places. So it'll be 0.0011. Now we have C, 7.4 times 10 to the ninth. We'll move this decimal 9 places to the right. So it'll be 7, 4, and then 8 zeros. So this will be our final answer for this problem here. So it'll be 7,400,000,000. Now we have 3.071 times 10 to the negative 6. We need to move that decimal 6 places to the left. So it'll be 0.000003071. That will be the final answer here. Now, it says now we are going to start the process of converting from decimal notation to scientific notation. Scientific notation is a form of multiplying decimals that's used primarily to write larger numbers in a shorter form using multiplication by an exponent of 10. So we have scientific notation. A number is expressed in scientific notation if it is written in the form d times 10 to the n power, where d must be a number equal to or greater than 1, but less than 10, and n is an integer. Writing a number in scientific notation. If necessary, move the decimal point to the left or the right to make the number equal to or greater than 1, but less than 10. Count how many places the decimal point was moved in step 1 to determine n. If your original number was 10 or greater, then your exponent is positive. But if the original number was less than 1, then your exponent is negative. You must multiply the number you obtained from step 1 by 10 to the number of the exponent you got in step 2. Now, let's apply what we just read. Okay, it says write each number in scientific notation. So the first thing we must do is we need to move this decimal and only have one digit in front of the decimal. That digit must be 1 or greater, but less than 10. So we'll move this decimal 2 places to the left. So we have 6.8945, and that'll be multiplied by 10 to the power of how many places we move, 2. But since we move left, it'll be positive. So this is the final answer. Now we come here, we move the decimal 1, 2, 3, 4 places. So it'll be 2.56 times 10 to the 4th. Now because we move to the right, that 4th power would be negative. Now number 3, it's assumed to be a decimal at the end of this number. So we'll move that decimal 1, 2, 3, 4, 5, 6 places. So it'll be 5.459231 times 10. And since we move to the left, it'll be times 10 to the 6th power. Now for number 4, move 1, 2, 3, 4, 5. So it'll be 7.2 times 10 to the 5th power. But since we move to the right, it'll be a negative 5. Now number 5, we move 1, 2, 3, 4 places. So this would be 4 times 10. And since we move to the right 4 places, it'll be to the negative 4 power. Now for 20, decimal is assumed to be here at the end. Move the decimal one place. This will be 2.0, or you could just write 2 times 10. Since we moved to the left 1, be 10 to the first power. Okay, now it says, oh, so that is it for the scientific notation.